All right. Hi. Hello, everyone. First off, thank you for inviting me to your forum. I'm Alex Marder, and I'm going to talk about how clouds use IXPs. All right. So first, who am I? I'm a research scientist at the Center for Applied Internet Data Analysis, otherwise known as CAIDA. It's an institute at the University of California, San Diego, and my research broadly focuses on trying to understand and interpret the internet. So here's a brief overview of this talk. First, I'll mention 3 papers that I didn't write, but I thought that people here might find interesting. Next, I'll go over my current research measuring and analyzing cloud wide area networks, or WANs. And then finally, I'll get to my preliminary measurement results from my work looking at how clouds use IXPs. So I'll start with the 3 papers. So the first paper asks the question, do you get better performance between cloud virtual machines and users over the cloud WANs or over the public internet? So on the slide, I put a picture of the cloud WAN for Google Cloud from their website, and Amazon AWS and Microsoft Azure also have these global WANs. And the result in the paper is a little bit unsurprising, but they confirmed that cloud WANs provide better performance in terms of latency and throughput than the regular traditional internet. And I bring this up because IXPs are well positioned to facilitate traffic using cloud WANs as long as possible. And there's now a peer-reviewed study showing that there's a benefit to doing so. All right, and the second paper focused on multi-cloud approaches and looked at how should someone with virtual machines in multiple clouds get traffic from one cloud to the other. The cloud WANs interconnect with each other. And on the slide, I've shown some of my own recent work trying to geolocate these cloud interconnections. And the paper found that using these WAN interconnections performed better than using a third party to transit traffic between the clouds, even when this third party was in the same data center as the two, was in an appearing data center with the 2 clouds. And then the last paper I want to talk about is from a colleague at CAIDA. He ran performance tests from cloud virtual machines in the US to speed test servers in directly connected networks around the country, and found the cloud WAN private interconnections do not appear immune to congestion. And this congestion could last minutes to hours. What this suggests is that it might be possible to use IXPs to provide alternate paths during sustained congestion events. So it might be worthwhile for networks that interconnect with clouds privately to also interconnect using IXP peering. All right, so now I'll talk a little bit about my current research agenda, which is trying to enable independent measurement and analysis of the large public clouds such as Amazon AWS, Microsoft Azure, and Google Cloud. Broadly, I'm trying to do 3 things. First, I want to create roadmaps for each of the major public clouds. I want to reveal and interpret the paths between cloud virtual machines and destinations all over the world. Second, I want to assess the impact of clouds on the public internet. It looks like there's a major internet evolution going on where the internet is shifting from a peer-to-peer model to a cloud-centric model. And specific to this talk, what is the impact on IXPs and how are clouds using the IXPs? And then third, I want to measure the performance along cloud application paths. And this includes detecting and locating congestion along those paths. All right, so just to reiterate what I'm talking about in this talk, I'm focused on this second goal. And specifically, I'm looking at how clouds use IXPs. All right, so now I'm going to discuss some of the preliminary work that I and some of my colleagues have done looking at clouds and IXPs. And I've got this initial set of questions that's guiding my research. Now, I'm guessing that everyone listening already knows that clouds participate extensively at IXPs. But the first question we asked is, where are the clouds peering? And for this analysis, we can simply use peering DB, but I will point out that our measurements appear to confirm the information in peering DB, suggesting that the clouds keep their peering DB entries well updated. So where do the clouds participate at IXPs? Well, they participate all over the world. So it's clear that clouds have put significant effort into participating at IXPs. And one thing that jumps out when looking at the map is that the clouds participate much more in Europe than the rest of the world, including the United States. All right, so now that it's clear the clouds participate at IXPs all over the world, a natural question is, who do they peer with? And how often are they peering with networks at IXPs to better reach customers of those peers? So to answer this question, we're using global traceroute measurements from the clouds. What we did was we set up a virtual machine in every cloud region. So as an example, the map shows all of the Google Cloud regions that currently exist. And from each of those regions, we conducted trace routes to all 11.5 million routed IPv4/24s. These are the /24s covered by a route announced into BGP. And then we interpret the paths revealed by our trace routes. And by interpret, what I mean is that we have an algorithm for inferring the network operator for each router represented by an IP address in the path. And we can also infer the network interconnections. So the top path is a path from AWS in Virginia to the University of Pennsylvania, where I did my PhD work. And using our algorithm, we discovered that AWS uses a private peering interconnection with Internet 2 to reach the University of Pennsylvania. Now, in this presentation, we're not especially interested in these paths, except to differentiate them from the IXP paths. And then in the bottom path, AWS uses an IXP peer, AWS uses an IXP peer, IXP to peer with Hurricane Electric. And using these traceroute paths that can reveal the cloud IXP peering, we can observe which IXPs the clouds use in each cloud region and the networks that they appear to peer with at each of those IXPs. All right, so here we're focusing on the paths where the cloud uses an IXP for the interconnection with the next top network. And we're trying to observe if the cloud uses the IXP to peer with networks just to get traffic to those networks, or if the cloud uses those peers to get traffic to other networks. So the peer acts as a middle network between the cloud and the destination network. Now in the top path, it's clear that AWS peers with Hurricane Electric. So Hurricane Electric acts as a middle network to get traffic to a third network. So in this case, we conclude that AWS peers with Hurricane Electric at the France IXP in Paris to get traffic to customers of Hurricane Electric. In the bottom path, we observe that Google Cloud peers directly with Cisco at the Equinix Ashburn IXP. And in all of our traceroute paths from Google Cloud through the Equinix Ashburn IXP, we never observed Cisco acting as a middle network. So in this case, we conclude that Google Cloud peers with Cisco at the IXP just to get traffic directly to Cisco, enabling them to bypass any providers. All right, so here's the fraction of IXP peers that we observe transiting traffic to other networks. And the results are split up by cloud and by continent. And it looks like all three clouds participated IXPs to peer with these middle networks. And they all, as well as to peer with networks that they never use as middle networks. But for each cloud, there are IXPs in nearly all continents where we only observe the cloud doing one or the other, peering with middle network or never peering with middle networks. And something the graph makes clear is that Google Cloud uses IXPs to peer with middle networks far less than AWS and Azure. And this might reflect the different IXP strategy that Google Cloud uses. In general, we observed far more IXP peers for Google Cloud than for AWS and Azure. And then the last thing I want to point out is that the clouds use IXPs in North America to peer with middle networks more than they do in other continents. All right, next, we looked at the latency from our cloud VMs to the IXPs. And this can provide an indication of how far the cloud data centers are from the IXPs where they participate. And we did this using the same traceroute paths as before and recorded the round trip time from the VM to the IXP hop. Then we took the minimum round trip time between the cloud VM and each IXP as an indication of the latency between them. So in this example, we observed the 1 millisecond round trip time between AWS in central France and the France IXP in Paris. Now, other than Azure in Africa, the clouds generally seem to have low latency between the cloud data centers and the IXPs. But there are some IXPs with relatively high latency, and this might provide those IXPs with the opportunity to provide additional value. So this map zooms in on Azure in Europe. And we can see that many of the IXPs have more than a 15 millisecond round trip time to the Azure cloud data centers. And this potentially opens up for opportunities for those IXPs to reduce the latency by hosting edge computing servers. So again, edge computing is when you try to move applications closer to the user. And cutting the latency by 15 milliseconds or more could affect the quality of certain real-time applications. All right, and then the last question we looked at is how frequently we observe the clouds using IXPs. Now again, we're differentiating when the next hop network is reached through private peering versus IXP peering. So first, aggregated across all regions, the clouds use IXPs to reach nearly 15 to 25% of the address space, but they use IXPs to reach 40 to 50% of the internet networks. And I think this difference might be explained by the fact that many of the networks with the most address space appear to interconnect privately with the cloud networks. And then once again, we compared the IXP usage across geographic regions. So one thing I thought was interesting is that on the right, when looking at the fraction of ASs reached using IXPs, it looks like North America is a bit of an outlier. The clouds appear to use IXPs to reach a greater portion of ASs in other continents. And then zooming in on Europe and North America, the two most mature internet regions, it looks like the clouds used IXPs about 2 times more in Europe than in the United States. And this is true both in terms of the address space and ASs reached using IXPs. Okay, so to wrap up, number one, the clouds participated IXPs all over the world, but they participate at far more IXPs in Europe than the rest of the world. 2, they use some of the peers as middle networks, although Google Cloud does this less than the other clouds. I can see in the Zoom chat, someone pointed out to me that in the business we call middle networks transit networks, and I agree. I'm referring to them as middle networks only to say that the cloud is using them to transit traffic to other networks. They might not use every transit provider at an IXP that way. Okay, 3, there's generally low latency between cloud VMs and IXPs, although some IXPs have the opportunity to potentially improve the latency for real-time applications. And then finally, clouds use IXPs to reach more than half of the internet networks. So it seems clear that clouds are an important part of the current WAN strategy for each of the 3 major clouds. All right, so thank you for listening. Obviously, I'm happy to answer any questions. Also, if you're willing or want to help us out, any data you can provide could be invaluable. I know that a lot of data is considered private for one reason or another, but an example of data that we could use would be the fraction of your IXP traffic that goes into or out of the clouds. And this can even be aggregated or anonymized. I'm also interested in what questions you think that we should investigate going forward. So you're all the experts in IXPs, so I'd love to know what problems or questions you think would be interesting for us academics to look into. And it's okay if you can't think of anything right now off the top of your head, but if you think of anything later on, you should feel free to reach out to me anytime, and I'd be happy to chat. So thanks again for listening.
Thanks, Alex. Great presentation. We've got some comments in swap card for you. The first question from Mark Brewer is, to identify a path through an IXP, did you use the Tray IX route? I'm not sure I'm saying that right. Or did you develop your own algorithm?
So it's less algorithmic than you might think. What we do is we use PeeringDB and EuroIX and IXDB from EuroIX to learn the IXP public peering address space. And then we have our own algorithm to identify where the border is of each cloud WAN. And if that border ends at the IXP, so we observe them using an IXP and the next hop network uses an IXP address, that's how we conclude that the cloud used an IXP on that path. We didn't use something like Trake's route, I think I'm not sure how it's pronounced exactly, because we weren't trying to figure out something like all of the different peering at IXPs, and we in our experience, we've generally seen that most of the public peering address space is listed in either PeeringDB or IXDB.
Thank you. I have one more question for you. Did you see any difference in performance between direct connections and IXP connections? And that's from Alexi.
Yeah, so that's a very good question. That's something we're hoping to look into going forward. Part of the problem with measuring performance in the cloud is that it's very expensive because you have to pay for egress traffic. So my colleague was using speed test servers to send TCP flows out of the cloud and could get a sense of the performance that way, but that was costing thousands of dollars a day initially. So we're working on ways to assess the performance without necessarily sending gigabits per second of traffic all day, every day. And we're hoping to try to figure out, do we see a substantial difference between private peering and IXP peering?
Thanks, Alex. I've got a comment from Luca Gicelli saying, nice hearing this data that confirms our feeling about cloud peerings of IXPs. Great presentation as well. And that's it. Alexi's asking if the dartboard behind you is part of your research. You don't have to answer that.
I sound better at research than I am at darts.
Well, thank you very much for the presentation. And as Alex said, if anyone has any questions or comments or data that they can share, please get in touch with Alex. I'm sure he'll be very pleased to hear from you. And hopefully, we will be we can invite you back to a physical forum for a longer presentation, because I think this is really interesting. So thank you, Alex.
All right, thank you.
Okay, so I think we are now coming to the end of our of our virtual event. So I'm going to say a couple of thank yous to everybody. First of all, everybody who's joined us today for the fourth virtual forum. I know it's not the same as meeting in person, but hopefully 2021 will be different. I want to thank the FPC and Rebecca, who have worked tirelessly on putting this event together, trialing out Swap Card, working with the patrons and the presenters to make sure that everything comes together nicely. I also want to thank the presenters. I think we've had some really interesting presentations and the panelists as well. It was a really great conversation regarding the IXP marketplace. And I'm really looking forward to continuing some of these discussions into 2021. But now I would like to invite you all to the end of year EuroX quiz. We will have a 5-minute break, so you've got 5 minutes to go grab a drink or a coffee. And please join us. Our quizmaster, Rob Lister, is going to be testing your knowledge on all things EuroIX related and just a little bit of technology thrown in there as well. So the URL for the Zoom will be put into the chat. With a 5-minute break, and we hope to see you all in the Zoom quiz room at 4 o'clock. Thank you. And hope to see you all soon, and stay safe.